In this lesson, we're going to look at angle properties in triangles. We know a triangle is a three-sided plane or two-dimensional figure. The sum of the three angles in a triangle always adds up to 180 degrees, and we've seen this before. So A plus B plus C all add up to 180 degrees. All those interior angles add up to 180 degrees. Now, what you may not have seen is that the exterior angle, angle D, equals the sum of the two interior opposite angles. So angle D is going to be equal to A plus B. The other important property is that C plus D, because they're sitting along a straight line, they're supplementary and they'll also add up to 180 degrees. So let's take a look at example 1 and use some of these properties. It says in the diagram, angle MTH is an exterior angle, so that's this one, 155 degrees. Determine the measures of the unknown angles in triangle MAT. So we know we can figure out this angle here, and we can figure out that angle because the two angles here sitting beside each other are laying along a straight line. So if we take, that's angle MTA, and that would be supplementary to 155, so 180 degrees minus 155 degrees. That would give us that angle MTA is equal to 25 degrees. We can write there that's because they're supplementary. Angle MTA plus angle MTH add up to 180 degrees. Now the only angle we have left here is angle A. And angle A we can figure out because all angles in a triangle add up to 180 degrees. And if we know that angle MTA is 25 degrees, we can just get that angle MAT is equal to 180 degrees, subtract the other two interior angles to give us an angle of 115 degrees. And that's right, that's because all angles in a triangle add up to 180. Now the other property you might want to use is that 155, right, if we're looking at that, 40 plus angle MAT should add up to 155, and that way you would also get the missing angle. Alright, let's try example 2. In example 2, it asks us to determine the measures of angle NMO. Let's figure out where that is. NMO, that's here. Angle MNO, which is this one here. And then angle QMO, which is this one here. Alright, so let's see what we're given here. We see that M to Q and R to P, those are parallel lines. Okay, and MN, the line MN, is a transversal here. And that's a transversal to lines LQ and NP. So I actually went from, instead of from M to Q, from L to Q. So we're saying that these two are parallel lines, and this line here is our transversal going through that. So we can use the ideas and the principles that we've learned to figure out what we're missing. So if we look at angle LMN, that's right here, 67 degrees. That angle and angle MNP, the one down here, this whole angle here, those two are alternate interior angles. Because these two are alternate interior angles, that whole angle then would be 67 degrees. But it's not just this little piece here, it's all the way down here. So if I know that that's all 67, then I can for sure figure out what angle MNO is if I just get rid of that 20 degrees and subtract it off. So first let's write down, okay, so I know that angle LMN is equal to 67 degrees, which also means that angle angle MNP is equal to 67 degrees because of that. So that also means that angle MNO is going to be equal to 67 degrees minus the 20 degrees that's sitting there to give me an angle of 47 degrees. So angle MNO is 47 degrees. I'm going to put a box around that so we can keep track, or draw a line through it. Put a box around that so we can keep track of it. The next piece of information I'm going to use is the fact that angle MNO, the one we just figured out, that 47 degrees, plus NMO, so where's that? NMO, this one up here, okay, plus MON, the 39 degrees here. I can use color here, so this angle here, and this angle here all add up to 180 degrees because the measures of the interior angles of a triangle all add up to 180 degrees. So if I use that, now that I have the 47 and I know the 39 that was given to me, I can figure out angle NMO. So let's do that. So angle NMO would be 180 degrees, subtracting off the 47 degrees, subtracting off the 39 degrees, to be left with an angle of 94 degrees. And so now we've solved the other one that we're looking for, and that's 94 degrees. All right, the last angle that we're looking for is this angle up here, right? Angle QMO, okay? For this angle, we can use the fact that all three of these angles here are sitting along a straight line, right? Here's our straight line. And because they're all sitting along that straight line, making a mess here, they are all supplementary and they add up to 180 degrees. That means that angle QMO is going to be equal to 180 degrees minus the other two angles, which are 67 degrees and 94 degrees. So angle QMO is equal to 19 degrees. And we're done part A of that example. In part B, it says in the diagram, QP is parallel, the symbol means parallel, to MR. So let's look at that. QP, they're saying, is now parallel to MR. Okay, knowing that, determine all these other angles. Okay, so I'm going to clean up the diagram and put in what we have. So here's our diagram cleaned up a bit. It's a little bit easier to solve what we're looking for in part B. And in part B, they want us to look at MQO, MOQ, NOP, OPN, and RNP. So let's go ahead and do that. Looking at our diagram, now that we know that those two lines are parallel, we also know that this is one possible transversal, and that intersects our two lines there. So that we're going to use that to help us figure out some missing information as well. Okay, so if we look at angle LMN, it's equal to angle MQO, and that's because they're corresponding angles. Which also means that angle LMN is equal to 67 degrees. Let's have a look. So angle LMN, if we're looking at here, this is our 67 degrees, and that's corresponding with angle MQO, And that angle is sitting right here. So those are two corresponding angles sitting in the exact same spot on the other line. So I'm going to fill that in. That's my 67 degrees there. Okay, the next thing we're going to look at is angle MOQ, which is right here, MOQ. Because we can see we've got a triangle here, and we know that in this triangle here, all three angles add up to 180 degrees, so I can solve that missing piece there. To solve this, we'll take the 180 degrees and subtract off the other two angles in the triangle. We'll get that angle MOQ is equal to 94 degrees. Alright, so we've done two of the angles. Now let's go and have a look at angle NOP. Okay, so angle NOP is sitting right here. Okay, and because we just figured out this one to be 94 degrees, we're going to use the principle that all three of these angles are sitting along a straight line. So now the angle here that we're solving for, we can also figure out by subtracting 180 minus 39 minus 94 to get what we want. So here's the math, 180 degrees minus 39 degrees minus 94 degrees to get us angle NOP to be 47 degrees. Let's go and put that in our diagram. Alright, the next angle we're going to be looking at is angle OPN, which is sitting right here. Now for angle OPN, we know that OPN plus MNP, which is right here, those two angles here are going to be interior angles on the same side of the transversal. This is our transversal here, right? So those two angles on the same side of the transversal between these two parallel lines, right? If we look at that. So we're seeing that this is one angle and here's the other angle. Those two angles are supplementary. They're going to add up to 180 degrees. And as we're adding more stuff, kind of creating a bit more noise, it's sometimes harder to see. But if I highlight those, you can see that's something that we've seen before. Okay, so let's solve for that missing angle. All we have to do is take 180, subtract the 47, subtract the 20. So angle OPN plus angle MNP are equal to 180 degrees, and angle OPN is equal to 180 degrees minus those other two angles, 20 degrees minus 47 degrees to give us an angle of OPN to be equal to 113 degrees. And that's because they're interior angles on the same side of the transversal, and those angles are supplementary. The last angle we have to solve for is angle RNP. Where's that? Let's get rid of this first of all. And put in what we just solved for. Okay, angle OPN was 113 degrees. And now angle RNP, where is that sitting? RNP is sitting down here. And we can see that that's also going to be 113 degrees because the two angles, this one and this one, are alternate interior angles again. Interior to what? Those two parallel lines that I just unhighlighted. Okay, so they're alternate interior. You might want to rotate your page sometimes, and it'll make it easier to see what you're looking for. So down here, running out of room, angle RNP is also equal to 113 degrees. And that's because they're alternate interior angles. That's it for this lesson. Thanks for joining me today.